Welcome to Chapter 16, Searching, Sorting, and the Vector Type Study Guide video. Please hit the like button, leave a comment, and subscribe to the channel. If you are unable to do that, you will need to log in. If you do not have a YouTube account, you can create one free, and it takes less than a minute. Let's get into it. 16-1 List Processing. A list is a collection of values of the same type. Because all values are of the same type, a convenient place to store a list is in an array, and particularly in a one-dimensional array. The size of a list is the number of elements in the list. Because the size of a list can increase and decrease, the array you use to store the list should be declared as the maximum size of the list. Given a sorted list of size n, a binary search makes at most 2 log base 2 of n plus 2 key comparisons. Basic operations performed on a list include the following: search the list for a given item, sort the list, insert an item in the list, delete an item from the list, and print the list. Suppose you have a list with 900 elements. If the search item is in the 900th element, sequential search makes 900 key comparisons. 16-1 are searching. Suppose that you have a list with 1000 elements. If the search item is the second item in the list, the sequential search makes 2 key, also called item, comparisons to determine whether the search item is in the list. Similarly, if the search item is the 900th item in the list, the sequential search makes 900 key comparisons to determine whether the search item is in the list. If the search item is not in the list, the sequential search makes 1000 key comparisons. Therefore, if search item is always at the bottom of the list, it will take many comparisons to find it. Also, if search item is not in list, then we compare search item with every element in list. A sequential search is therefore not very efficient for large lists. In fact, it can be proved that, on average, the number of comparisons, key comparisons, not index comparisons, made by the sequential search is equal to half the size of the list. So, for a list size of 1000 on average, the sequential search makes about 500 key comparisons. The sequential search algorithm does not assume that the list is sorted. If the list is sorted, then you can significantly improve the search algorithm, as discussed in the section Binary Search of this chapter. However, first, we discuss how to sort a list. We will be right back after this. Bubble sort. Many sorting algorithms are available in the literature. Chapter 8 discussed a selection sort algorithm. The selection sort algorithm sorts a list by finding the smallest or equivalently largest element in the list and then moving it to the beginning or end of the list. Next, we describe 2 more sorting algorithms: bubble sort and insertion sort. First, we describe bubble sort. Suppose list 0 to list n-1 is a list of n elements indexed 0 to n-1. We want to rearrange, that is, sort the elements of the list in increasing order. The bubble sort algorithm works as follows. In a series of n-1 iterations, the successive elements list index and list index plus 1 of the list are compared. If list index is greater than list index plus 1, then the elements list index and list index plus 1 are swapped, that is, interchanged. It follows that the smaller elements move toward the top, or beginning, and the larger elements move toward the bottom, or end of the list. Insertion sort. As noted in the previous section and in Chapter 8, for a list of length 1000, bubble sort and selection sort make approximately 500,000 key comparisons, which is quite high. This section describes the sorting algorithm called insertion sort, which tries to improve, that is, reduce, the number of key comparisons. The temp variable used in the swap code for the bubble sort in this chapter is used to hold the element with the larger value in the swap. Binary search. A sequential search is not very efficient for large lists. It typically searches about half of the list. However, if the list is sorted, you can use another search algorithm called binary search. A binary search is much faster than a sequential search. In order to apply a binary search, the list must be sorted. A binary search uses the divide and conquer technique to search the list. First, the search item is compared with the middle element of the list. If the search item is less than the middle element of the list, we restrict the search to the upper half of the list. Otherwise, we search the lower half of the list. Because we frequently need to determine the middle element of the list, the binary search algorithm is usually implemented for array-based lists. To determine the middle element of the list, we add the starting index first and the ending index last of the search list and divide by 2 to calculate its index. Let's look at the next section right after this. Performance of binary search. Suppose that L is a sorted list of size 1024 and we want to determine whether an item X is in L. From the binary search algorithm, it follows that every iteration of the while loop cuts the size of the search list by half. Because of this, the while loop will have at most 11 iterations to determine whether X is in L, because every iteration of the while loop makes 2 item or key comparisons, that is, X is compared twice with the elements of L. The binary search will make at most 22 comparisons to determine whether X is in L. On the other hand, recall that a sequential search, on average, will make 512 comparisons to determine whether X is in L. To better understand how fast binary search is compared to sequential search, suppose that L is of size 1,048,576. Vector type. Chapter 8 and the previous sections of this chapter described how arrays can be used to implement and process lists. The function clear can be used to delete all elements from a vector object. One of the limitations of arrays discussed so far is that once you create an array, its size remains fixed. This means that only a fixed number of elements can be stored in an array. Also, inserting an element in the array at a specific position could require the elements of the array to be shifted. Similarly, removing an element from the array could also require shifting the elements of the array, as we typically do not leave empty positions between array positions holding some data. Typically, empty array positions are at the end. The C++ vector type can grow or shrink during program execution. The statement vector veclist size creates a vector object, veclist, with size elements and initialized with default values. In addition to arrays, C++ provides the vector type, most commonly called the class vector, to implement a list. A variable declared using the vector type is called a vector container, or a vector object, or simply an object. Unlike an array, the size of a vector object can grow and shrink during program execution. Therefore, you do not need to be concerned with the number of data elements. The function size returns the number of elements currently held in a vector object. When you declare a vector object, you must specify the type of the element the vector object stores. With vectors, both the function at and the subscripting operator, the square brackets, return the elements at the specified position. We will be back right after this. 16-2a, vectors and range-based for loops. The header file that contains the class vector is vector. Chapter 8 introduced range-based for loops, which is a feature of the C++ 11 standard, and discussed how it can be effectively used to process the elements of an array. In Chapter 12, we explained that if a formal parameter of a function is an array, a range-based for loop cannot be used on that formal parameter. Moreover, in Chapter 12, we also explained why a range-based for loop cannot be used on dynamic arrays. However, a range-based for loop can be used on vector objects, even if they are declared as formal parameters to a function. The function max returns the maximum number of elements that can be inserted into the vector object. 16-2b, initializing vector objects during declaration. C++ allows variables of simple data types or arrays to be initialized when they are declared. For example, consider the following statements. Int x equals 90. Int list equals curly brace 2, 3, 4, 5, close curly brace. The first statement declares x to be an int variable and initializes x to 90. The second statement declares list to be an int array of 4 elements and initializes the elements of list to 2, 3, 4, and 5 respectively. In examples 16-5 and 16-6, we declared intlist to be a vector object of type int, and then used the function push_back to store int values in intlist. To be specific, the following statements were used to declare intlist to be a vector of int object and store 24, 39, 90, and 66 in intlist. The vector int intlist statements declares intlist to be an empty vector object with element type int. Let's start a quick review when we come back right after this. A list is a set of elements of the same type. The length of a list is the number of elements in the list. A one-dimensional array is a convenient place to store and process lists. The sequential search algorithm searches a list for a given item, starting with the first element in the list. It continues to compare the search item with the other elements in the list until either the item is found or the list has no more elements left to be compared with the search item. On average, the sequential search searches half of the list. The sequential search is good only for very short lists. To sort a list, say list of n elements, the bubble sort algorithm works as follows. In a series of ni-1 iterations, the successive elements, list index and list index plus 1 of list are compared. If list index is greater than list index plus 1, then the elements list index and list index plus 1 are interchanged. Insertion sort algorithm sorts the list by moving each element to its proper place. Binary search is much faster than the sequential search. Binary search requires that the list elements are in order. That is, the list must be sorted. For a list of length 1024, to determine whether an item is in the list, the binary search algorithm requires no more than 22 key comparisons. In addition to arrays, C++ provides the vector type, most commonly called the class vector, to implement a list. Unlike an array, the size of a vector object can increase and decrease during program execution. Therefore, you do not need to be concerned with the number of data elements. When you declare a vector object, you must specify the type of element the vector object stores. The elements in a vector can be processed just as they are in an array. As in an array, the first element in a vector object is at location 0. Suppose you have a list with 1024 elements. To determine whether an item is in the list, the binary algorithm requires no more than 22 key comparisons. The following functions can be used to perform various operations on a vector object: at front back, clear push, underscore back pop, underscore back empty size resize, and max underscore size. For a description of these functions, see Table 16-2. In C++11, a range-based for loop can be used to process the elements of a vector object. The C++ vector type can grow or shrink during program execution. If you found this video useful, please hit the like button, leave a comment, and subscribe to the channel. If you are unable to do that, you will need to log in. If you do not have a YouTube account, you can create one free, and it takes less than a minute. To see more videos like this, please click in the rectangle in the middle of your screen. To see other videos from this channel, please click the circle on the bottom right. Thanks again and have a wonderful day.